Here we have 4 different conic sections being represented here. We see that when we cut sideways, we get a parabola. When we cut in the middle but sideways, we get an ellipse. If we cut in the middle but straight, we get a circle, which is a type of an ellipse. And finally, if we cut straight down, we get a hyperbola. And today we'll be talking about the parabola. But before we get started, let's review what we know so far. In the past, we were graphing quadratic functions, and we had an equation like f of x is equal to ax squared plus bx plus c, and then we would complete the square to get it into standard form, which is f of x is equal to a times x minus h squared plus k, and then we would know where the vertex was because it was the coordinates hk, and if the vertex was a minimum value, the parabola opened upward, and that means that a was positive. And if the vertex was a maximum value, the parabola would open downward, and that means that a was a negative number. And we're talking about this coefficient here. And then we're also able to find the vertex by using the equation x is equal to negative b over 2a. And after we find what x was, then we can go ahead and plug in x into the function and get y, and that would also tell us where the vertex was. But this is what we did in the past. This is kind of like the algebraic point of view. But when we start looking at the parabola as a conic section, we start looking at it from the geometric point of view. So from the geometric point of view, if we have a parabola, I'll just draw this one opening upward. Then it's going to have a point somewhere here called the focus. And it's going to have a line somewhere about here called the directrix. And the geometric definition says that if we have any point along this parabola, then the distance between the focus and the directrix is going to be equal. But obviously in this picture I didn't really draw it perfectly, but these two distances should be equal. The distance from the point, any point on the parabola, the distance from the focus to that point, and the distance from the directrix to that point have to be equal. And also the distance between the vertex, which in this case is right here, the distance between the vertex and the focus, they call it P, is going to equal to the distance from the vertex to the directrix, which is also going to be a distance of P. And then straight down the middle, we have our axis of symmetry. And knowing the relationship between the focus and the directrix is really going to be important when we solve problems from the geometric point of view of the parabola. We just have to remember that the distance between the vertex and the focus is the same distance from the vertex to the directrix, and it'll really help us when we solve problems. For now, we're just going to look at parabolas centered with the vertex centered at the origin at 0, 0. But in the future, we will look at shifted conics. But for now, we're just going to look at the parabola being centered at the origin, 0, 0. And we can make a few generalizations. If a parabola opens up or down, then it's going to have the general form x squared is equal to 4py. But if the parabola opens left or right, it's going to have the form y squared is equal to 4px. And then we can tell if it opens upward or downward, if p is positive or negative. So if we have a upward parabola, that means that p is positive. And then if we have a downward opening parabola, that means that p was negative. And then the focus would be the point 0, p. The focus here would also be 0, p. And the directrix is going to be y is equal to negative p. And the directrix here is also going to be y is equal to negative p. And then if we look at the other side, at the left or right parabola, then we're going to have a parabola that opens to the right if p is positive. And then we're going to have a parabola that opens to the left if p is negative. And then once again, the focus here is going to be p, 0, because it's on the x-axis. And then here it's also going to be p, 0, being the focus. And then this time the directrix, instead of being y is equal to negative p, it's going to be x is equal to negative p. So that also helps you tell if it's going to open left or right or up and down, as if the directrix is in the form y is equal to negative p or x is equal to negative p. And one way to maybe help with remembering if it opens up or down or left or right is we're used to seeing the x being squared. So if the x is squared, it's probably pretty normal looking. It's going to open either up or down depending on if p is positive or negative. But if y is squared, we're not really used to seeing that. So if y is squared, that tells us, okay, it's probably going to be left or right, and it's going to depend on the sign of p, if it's positive or negative. Okay, now that we got an overview, let's practice a few problems. We're asked to find an equation for the parabola with the vertex at 0, 0 and focus at 0, 2 and sketch its graph. Okay, so if the vertex is, let's make a sketch here. The vertex is at 0, 0. We're not doing shifted conics yet. And it says that the focus is at 0, 2. So 0, 2 is right about here. And just from where the focus is, that tells us that this is a parabola opening upward. If the focus was here, it would open this way. If the focus was here, it would open this way. And if the focus was here, it would open that way. So based on where the focus is, it tells us that it's opening upward. And if it opens up or down, we know that it's going to have the form x squared is equal to 4py. So what we need to do now is we need to find what p is. And as we talked about earlier, p is just the distance from the vertex to either the focus or the directrix. So in this case, we have the focus, and the distance is going to be 2 because the vertex is at 0, 0 and the focus is at 0, 2. So this distance is 2, and that means that p is equal to 2. And if p is equal to 2, then our equation should be x squared is equal to 4 times 2y, which we can write as being x squared is equal to 8y. And that's it. We got our equation. And then if we wanted to, we can go ahead and add the directrix. So the directrix is going to be the same distance as the vertex and the focus, except in the other direction. So it's going to be 2 units down we're going to have our directrix. And because it's an up or down parabola, in this case it's an up parabola, the equation is going to be x is equal to negative p. So p is 2, so this should be x is equal to negative 2, and that makes sense because this is a distance of 2. And this is our directrix. Alright, let's look at another one. A parabola has the equation 6x plus y squared is equal to 0. Find its focus and directrix and sketch the parabola. Okay, this time we see that we have the y being squared, which is kind of weird. It tells us it opens either to the left or to the right. So let's go ahead and get it into its kind of general form, which is y squared is equal to 4px. So we have the equation 6x plus y squared is equal to 0. We're going to subtract 6x from both sides, giving us y squared is equal to negative 6x. Okay, so now we're in this form. And once again, like we did before, we're going to compare the coefficients. So the coefficient here is negative 6, and the coefficient here is 4p. So we're going to say that 4p gave us negative 6. So 4p is equal to negative 6. And now we can go ahead and solve for p. So dividing both sides by 4, we get p is equal to negative 6 over 4, which simplifies to negative 3 over 2. And because p is negative, that tells us that the parabola is going to open to the left. So I'm going to sketch the graph. Once again, we know that it's centered at the origin because we don't have any shifts. We don't see a 6x plus something or, a y plus or minus something squared. It tells us that it's at the origin. Okay, so our parabola opens, it's centered at the origin. It's going to open to the left. We know what p is. P is negative 3 over 2. The focus is going to be a distance of 3 over 2 in this direction, which means that its point is negative 3 over 2, 0. And then we also know that the directrix is going to be also the same distance, but in this direction. And it's going to be a vertical line. And this line is going to be x is equal to 3 over 2. And we also know that the directrix, we can also just say that the directrix is x is equal to negative p. P is negative 3 over 2, so the directrix is x is equal to 3 over 2. And we can just verify that by looking at the distance. This is for you guys to try on your own. So go ahead and pause the video and try to find the equation for this parabola. Otherwise, the answer will be revealed in 5 seconds.